You want to design your aquaponics system. You either have a specific area to build your farm, or you want to size your farm to meet a specific vegetable production target. We have designed the Ceres Production app to answer your questions. What greenhouse size do I need to achieve my production target? How much space do I need to produce each crop? How many seedlings do I need to seed weekly? How does climate affect my production? What will be the impact on my productivity if I add grow lights? How many fish do I need? How much should I feed the fish daily? What should be the size and number of fish tanks required? What are the best practices for growing each plant? Will I need to supplement some minerals? What is the optimal spacing for growing my vegetables? Which growing process will give me optimal productivity? So many questions that Ceres Production answers. Ceres is not an AI app. It has been built using actual production data recorded over many years in aquaponics labs and farms under various environmental conditions. It is very straightforward to use. First, we select our preferred unit system, metric or imperial. Then we input the environmental parameters of our farm, daily light duration, and water temperature. The water temperature significantly affects plant growth. The next step is to enter our targeted crop. Ceres Production includes 5 models for 5 plant types. Small plants grow in batches, such as lettuce, cabbage, or kailan. Small plants grown continuously, such as rocket arugula, spinach, or watercress. Cooking herbs. Mid-sized plants that will need more vertical space, such as kale, basil, celery, chili, broccoli. All these plants can be grown in a stacked system. The 5th type includes tall plants that need a single-level growing system. Ceres Production accepts up to 6 different vegetables per type. Select a vegetable. Let's grow some butterhead. Enter the required monthly production. We want 60 kilograms per month. We enter the sales price, or the estimated cost price if we build an in-house farm for a restaurant. Ceres will provide us with an overall financial summary and a productivity comparison per area unit, square meter, or square foot. So we will be able to compare productivity and revenue across all our selected vegetables and decide whether a specific vegetable is worth producing or whether it would be more profitable to allocate the space to another vegetable. Ceres provides us with valuable information: the expected productivity under our defined environment, the optimum harvesting weight, the growth duration to reach this weight, the number of plants we will have in our farm to achieve our desired production, the average plant density, the area required. Ceres Production also provides monthly plant production, revenue per unit area, and overall monthly revenue for each vegetable. Small plants in a batch require a heavy seeding process. It is therefore critical to also design the required germination and nursery areas. We seed in sponge blocks. After 7 to 10 days, the seedlings reach 4 leaves. We place these sponge blocks into pots and keep them in a tray nursery for 2 weeks. These processes have a specific performance, and we will need to generate a slightly larger amount because some losses occur during growth. AHAS germination efficiency reaches 97%. This is highly dependent on the quality of the seeds used. We will probably also lose 5% of the seedlings during the nursery process. Ceres provides us with the weekly seeding requirement, the germination and nursery space required, and will later provide the total space required once we have entered all our crops. When the plants have grown to the size of the pots, we place them on the floating board at 100% density. Later, once the plants touch each other, we split the 100% density board into 2 half-density boards for the second growth period. Some plants can be harvested at half density, others require splits to quarter or eighth density. Ceres advises the optimum growing density process for each plant. Compared with a single density growth process, a variable density growth process increases yield by up to 55%, while requiring very little manpower to adjust densities. Ceres provides an optimized growing plan for each vegetable, based on AHAS's 10 years of experience and experiments in labs and farms. Ceres Production also provides us with detailed information on each plant. Let's enter the remaining small vegetables we plan to grow. Now that our small plants in batches are done, we focus on small plants grown continuously. We will grow 20 kilograms of rocket arugula per month. Let's continue with our cooking herbs, mid-sized plants, and tall plants. Now that we have entered our desired crops, let's design our farm. We need to tell Ceres the width of our greenhouse, the size of our grow beds, and the width of the walkways between lines and on the sides. Our greenhouse is 12 meters wide. Our grow beds are 1.2 meters wide, and the growing boards are 90 centimeters wide. Since we want access for disabled people, we will design the farm with 1.2 meter wide walkways. We will also have 1.2 between the end of the lines and the greenhouse wall. Ceres confirms the walkways between the sides of the grow bed and the greenhouse walls are 1.2 meters wide. We will have space for 4 lines. Since we are growing tall plants, our cherry tomato, we will need a single level line. If we also use single level lines for the other plants, our lines will need to be longer than 28 meters. Let's go for 2 level lines. With double growing level lines, our lines should be 14 meters long. We will have 3 lines allocated for our mid-sized plants and 1 line for tall plants. Our tall plant line will have an extra 3.7 square meters available. We will use this space for experimentation. Our farm will be at least 12 meters wide and 16.7 meters long. Let's focus on our fish engine. Ceres computes the required water mineralization for all these plants to thrive. We enter the water depth in our grow beds, 25 centimeters. Then, Ceres advises us on the initial mineral supplement required. The fish food we will use contains 38% proteins. Proteins are converted into nitrates that plants grow on, and the higher the fish food's protein content, the less fish food is required. We will need to feed our fish 2.3 kilograms daily. Ceres also advises us on the regular additional mineralization our farm will require. These are based on individual needs for each of the vegetables we selected. The next section designs our fish engine. Based on our farm's mineralization requirement, Ceres provides the required number of fish, the number of fish per tank after we have adjusted the number of tanks, and the total weight of fish in the system. Ceres advises on the minimum number of fish tanks and their sizes, but we can adjust these. For this initial design, we will have 3 tanks or 1.6 meters in diameter, so we can have a more powerful fish engine in case we need to use our aquaponics water to fertilize offline plants in pots on the sides of the greenhouse using a drip system later. Since we have 3 tanks and we plan to grow our fish for 12 months, we will need to replace the fish every 4 months. We need to make sure our fish have enough space to live. This is measured as the quantity of water per kilogram of fish in the tank housing the large fish. Ceres assists us with this calculation. Ceres includes an advanced fish growth model and advises us on how to split the amount of fish food based on fish size. To evaluate our fish business, we tell Ceres we will harvest fish at 750 grams after 12 months and sell them at $6 a kilogram. The remaining sections are our summary reports, our weekly seeding and density growing plan, the germinator and the nursery area required for our farm, and our production and revenue summary. In this report, we can easily compare each plant's performance with the others. To design a farm starting with a specific area, we use the second Ceres production options. We start with designing our farm layout, and then we input the crops. At each step of the crop selection process, Ceres displays the remaining available area. Once our crop selection is entered, the mineralization, the fish engine size, and the report sections are the same as in the first option. Ceres Production gives us much of the information needed to design our aquaponics farm. The AHAS team has been designing and operating farms for over a decade. You can access Ceres Production for a very low fee. Ceres Production is also available in multiple languages. If you need more support in building your farm, AHAS also offers a Ceres Professional package that includes design assistance, farm hydraulics design, power and energy requirements, solar system requirements, and project financials, including operating costs, required capital, and expected return. In addition, the package can be extended to include 1 year of companionage services, during which you receive dedicated support throughout the design, construction, commissioning, startup, and operating phases of the project. Visit the Ceres Professional page on AHASservices.com for more details.